Hello everyone. The work I'm going to introduce is entitled Optimal Two-Level Charging Station Pricing, Considering Electric Vehicle User Price Elasticity. This presentation will include an introduction, the proposed operating regime, the experiment results, and the conclusions. The background of this work is that climate change is threatening the human society and causing a worldwide trend for carbon neutralization. Under this trend, the electric vehicles are rapidly developing and replacing the conventional vehicles. And the contributions of this work including considering the price sensitivity of EV users in selecting a preferred charging station to park and charge, and a two-level optimal pricing strategy is proposed to increase the market share of the considered charging station and optimize its load profile. Also, a solution methodology is developed to address the multilinear terms in the formulated problem. The proposed operational regime considers a charging station that is located in urban area with its competitors. The customer pool of the considered charging station is considered relatively stable, but they also have different thresholds for charging prices. That is, when they think the charging price of the charging station is too high, they can choose to park and charge at some other rival charging stations. The considered charging station is a price taker that purchases energy from the energy market to satisfy the EV charging requirement, and it is motivated to shift the EV charging load from high price hours to low price hours to reduce its energy bill. And we consider a flat charging price for the EV users and use incentives to change the charging behavior of the EV users. In this work, the user price sensitivity is considered from two aspects, including that EV users expect to recharge their EVs at acceptable prices. Also, they can also accept the incentives from the charging station to schedule their charging behavior. When the higher the incentives from the charging station, the more the EV users would like to reshape their charging load profile. The problem of this work is formulated as a profit maximization for the charging station, and in this work we have considered the user sensitivity constraints, the EV charging power constraints, and the EV state of charging constraints. In this problem formulation, we have some multilinear terms that will introduce non-convexity to the problem, making it difficult to solve. Hence, we used the big M theory and the McCormick envelopes to linearize those multilinear terms. To linearize this trilinear term, we used the equivalence relationship and introduced an auxiliary variable to make the transformation. And based on the big M theory, we added some bounding constraints on the transformed terms. To handle this bilinear term, we replaced the bilinear term with an auxiliary variable and added those corresponding constraints based on the McCormick envelope. To verify the effectiveness of the proposed method, we used the real-world data from the Nord Pool day-ahead market, and the EV users are assumed to follow a uniform distribution for their acceptable prices. In total, we have tested 200 electric vehicles over the operating day. The profit of the charging station is affected by how many EV users will participate in the charging station and how much money the charging station can make from each EV user. That is, high price will lead to lower number of EV users, but gives higher individual profit from each EV user. And for low prices, they will lead to higher number of EV users, but lower individual profit from each EV user. Hence, we need to find a compromise between these two. And by using the proposed method, the highest profit of the EV user can be achieved when the price is can achieve about 80% of participation. Also, under the proposed incentive program, the EV charging nodes at those high price hours are shifted to the low price hours to increase the benefit of the charging station and also increase the benefit of the EV users, as shown in Figure 7. From Figure 8, we can see that as more EVs choose to park and charge at the considered charging station, the charging station profit will increase proportionally. And the profit from the incentive program also increases proportionally as more EV users participate in the charging station. Hence, in this work, we have introduced a pricing strategy to attract EV users and regulate their charging behaviors. The proposed method explicitly considers the price sensitivity of EV users to decide how many EV users will be attracted to the considered charging station. Also, the numerical result shows that by using the proposed method, the revenue of the charging station can be significantly improved. Thank you all for your listening.